Hello guys, so in this video we'll be looking at how we should find the mean and variance of binomial distribution using MGF, that is moment generating functions. So in this video we'll be finding mean and variance of binomial distribution using MGF, that is moment generating function. So let us try to solve this. So if you remember, the moment generating function is nothing but the m of x. So m of x can be, m of x formula is expected value of e power t of x. So let us make a note of it. So MGF of binomial distribution distribution. So we know that mx of t is nothing but the expected value of e power t of x. So e power t of x can be written, actually we are dealing with binomial distribution, right? So in binomial distribution, what will be, so what is the notation is nothing but the p of x. So now we can write this exponential of x equal to 0 to n e power t power x, that is the moment generating function, into p of x. P of x nothing but the binomial distribution. Why are we doing this step? Because we need to find the binomial distribution based on the MGF. So we know that sigma x is equal to 0 to n. What is e power t of x? Is nothing but the e power t of x. What is p of x in binomial distribution? P of x in binomial distribution nothing but the ncx p power x q power n minus 1. So ncx p power x q power n minus x. So if you can see that here two powers are equal, that is x as well as e power t power x. So what if we remove the x common, and what if we merge the two values, that is x is equal to n e power t into p whole power x ncx q power n minus x. So this will be the actual equation. So now what you have known, so before I have told you in the previous video that anything which will be resulting in the form of ncx p power x q power n minus 1 can be written as p plus q power n, right? So now you see that it is same as the ncx p power x q power n minus x. You can see that ncx is common. So what is p? P is nothing but the p into t power x plus q power n minus x. So this can be written as p plus q whole power n. So what is p plus q here? What is p? P into e power t plus what is q term? Q is nothing but the p power n. So what we have got, mx of t, that is binomial function in MGF, we got it as p into e power t plus q power n. So this is the actual equation in MGF. So now let us find the mean as well as the variance. So that is known as raw moments. So mean is defined with mu1 dash is nothing but the mean. So mean is equal to, so in what will happen if how we should find the mean in binomial distribution. So we have to derive it. So from the derivation we can find the mean, and if you do double derivation we will be getting a variance, that is sigma mean. Variance is nothing but the sigma square, right? So mean is equal to d by dt mx of t such that t equal to 0. So this is a derivation step. If we derive that, we will be getting a mu value. So let us try to derive it. So d by dt of what is mx of t? Mx of t is nothing but the p into e power t plus q, that is p into e power t plus q such that t equal to 0. So now let us try to, so we have whole power n. So now let us try to derive this, differentiate it. So with respect to t we have to differentiate. Just keep in your mind that q is the constant and p is the product term of with respect to t power t. So t is the power of n. So now let us define. So we know that d by dt of x power n is nothing but the n into x power n minus 1 d of x. So if it is read by x, so this is a formula, right? So now based upon this formula we will be differentiating it, that is n into p into e power t plus q. So now we have to derive differentiate with respect to t for this term also. So what is q? Q is nothing but the constant term. So what is p? P is the product term, and e power t will be e power t itself, that is p into e power t, such that t is equal to 0. So now let us substitute the, now let us get 20. It is 0, that is n into p e power t of p into e power t plus q. So this is the equation we have got, that is 0 is not there. So p e power t get into n beside the n, that is n into p into e power t, and this term enter term written down, so it will be okay. So now let us try to substitute t equal to 0 in this value. So we know that e power 0 is nothing but the 1, and we also know that p plus q is equal to 1. So now let us substitute t equal to 0, that is n into p per e power 0 of p into e power 0 plus q. So what e power 0 is? E power 0 is nothing but the 1, and p power 0 is nothing but the 1. So p plus q we will be getting. So we know that p plus q is nothing but the 1, that is np of 1 is nothing but the np. So mu dash of mu 1 dash is nothing but the np. So what in binomial distribution, what is the mu value? In binomial distribution, mu value is nothing but the np. So in moment generating function also, so based upon the function we have got in moment generating function, so we have derived the mean also. So now let us derive the variance. So variance is nothing but the double derivative of the moment generating function. So that is variance, we are finding for variance. So variance is nothing but the mu 2 dash. Mu 2 dash is equal to d square mx of t by dt square, such that t equal to 0. So we have already differentiated it, right? So that is d by dt of d into mx of t by dt, such that t equal to 0. So what is the differentiation of mx of t into t? So we have already differentiated it. So we got differentiation as n into e power t plus p into e power t plus q. So we have to take the equation before the t is substituted. So in this equation we have substituted t value. So before the t substitution we have to take, that is this is the differentiation, that is first order differentiation of the MGF. So now let us take this equation, that is d by dt of what is the differentiation? np into e power t of q plus p e power t of n minus 1. So this is the equation, right, we have got here. So you can see n into p power t plus q into p into e power t. So in 12th standard we have learned that, so d by differentiation of any uv, differentiation of eb can be written as u dv plus v du, right? So u dv plus v du. So now we have to differentiate based upon that. So here what is the constant term? Here np is the constant term. So get from the equation, that is np into d by dt of e power t into q plus p into e power t per n minus 1. So this is the equation. So consider e power t as u and this one as v. So now let us differentiate with respect to t. So I have already shown you the formula that differentiation of uv is nothing but the u dv plus v du. So let me write the np of what u is nothing but the e power t. So e power t into differentiation of this one v term. So differentiation of v term is nothing but the n minus 1 will be getting down of q plus p e power t power n minus 2 it will be, and we have to differentiate it, it is also again. So q is 0. Now we will be getting p e power t, that is 0 plus p e power t. So one term is completed. So let us move to the another term, that is v du. So what is v? V is nothing but the q plus p e power t. What is du? D is nothing but differentiation of et. So what is differentiation of et? Differentiation of et is nothing but the different e power t itself. So this is the equation we got. So now let us try to let us take into the one step. So e power t into n minus 1, and we'll be getting q plus p e power t power n minus 2, and 0 just remove 0, and p e power t plus, and this one e power t of q plus p e power t. So here such that t equal to 0, such that t equal to 0, such that t equal to 0, such that t equal to 0. So now let us substitute the t value in the equation. So I will be writing this step directly, that is e power t, e power 0 is nothing but the 1, right? So e power 0 it will be 1 itself, and here it will be 1. So here it will be 1, here it will be 1, here it will be 1. So what is the remaining term? Remaining term I will be writing np. So this one will be e power 0, that is 1. So n minus 1 will be having. So here into q plus p. So e power 0 is nothing but the 1, is nothing but n minus 2. E power t is nothing but the p will be getting, plus e power 0 is 1, and here we will be getting q plus p value, e plus p value. So this is the entire equation. So now actually we have forget to write the n minus 1 upon here, so just make it a note. So n minus 1. So now we already know, we also know that p plus q is equal to 1, right? So let us substitute p plus q is equal to 1. So what will happen if p plus q is equal to 1? This term will be entirely removed, and this term will be entirely removed. So what will be the equation then? So we will be having a equation np of n minus 1 into p plus 1. So we will be having this equation. Just remove this. So we will be having this entire equation. So now we have to multiply the np into upon this. So n of n minus 1 into p square plus np of 1 is nothing but the np. So we got mu2 dash as n of n minus 1 into p square plus np. So what is the formula for variance? Variance will be deriving as, so variance of binomial distribution will be mu2 dash is equal to mu2 dash minus mu1 dash whole square. That will be writing as e power x square minus e power x whole square. So what is e power x square? E power x square is nothing but the n into n of n minus 1 into p square plus np minus e of x whole square. What did we get e of x? E of x nothing but the np. So now that is np whole square. So now let us multiply this. So we will be getting n square p square minus np square plus np minus. So now just apply square, that is n square p square. So now what other term will be getting cancelled? So we will be getting cancelled this one as well as this term. So what are the remaining term? That is np minus np square. So now let us remove np. Let us take the np as common. We will be getting np of 1 minus p. So we know that p plus q is equal to 1. So what is the value of q? Q is nothing but the 1 minus p. So in this place we can substitute q, right? That is np q. So what did we get the variance? So variance we got as npq. That is the actual solution. So mu we got as mu1 dash is nothing but the np, and mu2 dash we got as npq. So this is the actual process. So where will be where MGF is used to derive the binomial function. So what we have discussed so far? So we have discussed the binomial distribution, that is a moment generating function, binomial distribution using MGF, moment generating function. So moment generating function is nothing but the expected value of e power t of a t power x. Then we have taken our binomial distribution formula, then we have multiplied it, and later we have derived the binomial function based upon the moment generating function. So then they went on with the finding the mean value. So mean value is nothing but the first order derivative of the MGF function. That is, we have derived the entire function, and then later we have substituted, that is t equal to 0 value. Then we got the mu as NP. So then later we have moved on to the finding the variance. So variance, how we can get the variance? So variance will be getting by the double derivative, that is d square by dt square mx of t. So we have already derived the first order derivative of mx of t. So that's why we have written the entire formula, entire step in this process, and later we have differentiated it based upon the two values, that is mu dv plus v du. That is, u is nothing but the e power t, and v is nothing but the q plus p into e power t power n minus 1. So before one kind suggestion for my viewers is that just before starting this video, or before watching my videos, just try to remember all the integrals formulas, differentiation formulas, so it will be easy for you to understand the topic. So okay, so now later then we went on with the expansion with this expansion. So after that we have substituted the t value, t is equal to 0 value, then all the e power terms will disappear. Then we have substituted the p plus q is equal to 1 value, that this term has disappeared and this term has been gone. So what is the last value we got? N into n minus p, n into n minus 1 into p square plus np. So this is actually equation then we got. So we will be finding a variance in binomial distribution. So we will be finding a variance based upon this formula, that is subtraction of mu 2 dash minus mu 1 dash whole square. So then later we have derived the entire formula, and we got the final variance as npq. So this is the actual process. If this process came in an exam, so then don't get any panic. So this is a small simple 10 minutes solve, so you can do it as soon as possible. So this is the actual process. Hope you got how to do it. Thank you.